Hey guys, what is up and welcome back. I'm going to quickly be showing every single review page and reteaching the concepts basically for the review so you guys can have this to prepare for the test that is on Monday. So make sure you've been studying hard. I'm going to put in these videos as soon as I can. So, well, you guys don't need to know that. When the video's up, you'll have already seen it. So, all right, the subject of this test, I would say the entirety of Unit 4, Part 2, and I have a blank page because I want to make a map for you guys before we actually get started working on the actual review. The basic idea, and I'm sorry, my voice is so strained, I don't know what I did, so I'm sorry, I'm trying to be as enthusiastic as possible, but it's killing me. So the theme of this entirety is really triangle congruence. Triangle congruence. We want to know, when are triangles equal? When are triangles equal? So that would look something like if you had two triangles. Triangles are congruent. Shapes are congruent. Really any shape in general, not just triangles, but any polygon in general. They're congruent when their pieces are all the same. All their pieces are the same. So like we would say these two pieces are the same. These two pieces are the same. These two pieces are the same. So all the sides are the same. So you would say all sides are congruent, and all angles too, we'll see in a second, are congruent. So maybe we can, also mark these angles to show that they're all congruent. That's why when you see congruent triangles, we've been seeing these shapes so much. We want to repeat. To say these triangles are congruent, they would have to have, now the triangles I've drawn, they're obviously not congruent. I think I don't draw them the same size. That's okay. Congruence requires same size, same shape. So maybe like a checkbox. Same size, same shape. And that can be achieved by these two pieces. Same size would be all the sides are the same. Same shape would be all the angles are the same. So for triangle congruence, this is the basic idea. Now, whenever we are actually talking about triangles, usually they're labeled. And the result of this convention, so that you don't actually have to see the triangles, what you do is you have a naming convention. So over here I'm going to make a branch, and at the top we'll do a naming convention tab. The order matters. So the most important thing about this, I would say, order matters. So like whenever you label your triangle, the order you're actually talking about, these points, matters a lot. So for example, this triangle is congruent to, you could say ABC is congruent to DEF. So here I'll say triangle ABC, here's an example, is congruent to triangle DEF. And this is you'd call this a congruency statement, or statement of congruency. A congruency statement of congruency. And note the order here matters. You can see in the notation, angle A corresponds to angle D. So it shows you which pieces are congruent in the triangle, which pieces are corresponding. So maybe over here I'll write that. It shows you the corresponding parts. The corresponding parts of the triangle are given in this example. So corresponding parts can be given by the naming convention that we use to name congruent triangles. The goal is, are two triangles congruent, right? So that's the entire subject of this first part. So everything we're going to do on this first page, I would say this is all page 1. Everything we're going to do on page 1 is going to be one of these things until we get to the very bottom, and then I'll recap some stuff. All right, so we'll add stuff as we go to this sheet. We'll keep coming back to it. That'll be a good way to keep track of everything that's going on. So on the first page of the review, now this is what you're here for. What do we actually do, Mr. Shirley? What does this mean, bro? All right, so here it says, given that triangle GIV is congruent to triangle LOT, complete the table of pairs of corresponding angles and sides. Okay, so great. What we want to do, what we would like to do is get this, let me see. We would like to, since these guys are congruent, we like to show which sides are congruent and which angles are congruent in the particular triangle. Now, the order of this notation matters, right? We just saw that the order of this notation is super important. So the order of this notation tells us exactly what is going on in the triangle. If it helps you, you can always draw a picture of your triangle. Now, I don't know exactly what these triangles look like, but it doesn't really matter. This could be G, I, and V. And as long as we go in the same order here, L, O, and T, we can recall which sides and stuff will be the same. So for the sides, we'll say GI must correspond to LO. You can see that GI and LO both go first. So you could say that the segment GO is congruent to, whoa, that's what I want to say, sorry. Segment GI, my bad. The segment GI is congruent to the segment LO. You could continue on. The next segment would be IV is congruent to OT, the segment. And then finally we have on the back side, the triangle actually wraps back around, right, to close itself. So it would be a VG is congruent to, and then here we have TL. Beautiful. Same thing, we also know the angles are the same. So we could tell the corresponding angles, the order of these letters tells us the corresponding angles in this case. So we would say G corresponds, maybe I haven't said it explicitly, but truthfully, corresponding just means that these are the congruent pieces of the triangles, right? So like G corresponds to L because it's the same angle in the respective triangle. If you were to move this triangle on top of the other one, G and L would be the same. So they correspond to each other, just like the corresponding angles from transversals. So in this case, angle I is congruent to angle O, and finally we have angle V is congruent to angle T. So too long, didn't read. Each letter, the position tells you its corresponding piece in the other triangle across the congruency sign. So G goes with L, I goes with O, V goes with T, and then we would GI, IV, GV, LO, OT, LT would be all the combinations. So here we have all the sides listed and all the angles listed. That shows those triangles are congruent. So to write a congruency statement for the given triangles, we would just need to find the correct order, and there are 3 possible correct orders. We could write the correct order for this piece and this piece. Now, I just like to go up and down, so I'm going to pick this way. You can go GSP, GPS, you can go PGS, SPG, tons of ways, however you want to do it. There's a bunch of different ways to do it. I'm going to write mine as GPS just because that sounds cool. So I'm going to write triangle GPS. Now, the first one I pick, it doesn't really matter, right? It can go in any order because now all I have to do is find its respective piece on the other triangle. So here I notice that from G to P, the length here was 8. So over here, the length is also 8. So it looks like if this is 8 and this is 8, then to capture the side, I need to start with either R or F, but I don't know any angles. So what I need to do is make sure that my point I pick first over here, G in this case, goes with a point that's between 8 and 10. And here I see 8 and 10, so it must be R that I want to pick first. So my first letter should be triangle R. And then since I'm going in this direction, I can kind of say, oh, the next one has to go with 8, so it must be F. And the next one has to go with 5, so it must be K. So triangle GPS is congruent to triangle R of K. Since all we want to do is give a congruent statement for the triangles, we are done with this question. This is all we wanted to do. Check. All right. In the next one, we're given a congruency statement. And here we'll have to use some of our knowledge of triangles. So maybe it's a bit of a refresher. We'll see in a second. But we would like to find the values of all the variables. Find the values of all the variables. That just means if it's a letter, what is it? So in a number, I guess, what's the number form of this variable? So here we see, excuse me, gosh, my voice is dying. Here we see a bunch of letters, X, Y, Z, and D. So there should be 4 answers. I should get 4 answers here for this problem. First, I notice these triangles are congruent. They're given as congruent. That means that all their parts are congruent. And in fact, we know that corresponding parts of congruent triangles are congruent, CP, CTC. We'll recap that more later, so don't worry about it now if you don't remember. But we know that all the corresponding parts of triangles are congruent, so I see that X is congruent to, and I know, see, X is between Y, this angle here, and 67. Oh, and I shouldn't even say that, should I? Oh, no, I'm crazy. I'm sorry. I noticed that X is between A and C. I don't know why I said that, guys. My bad. Tired, too. We know that X is between A and C. So from A to C, that corresponds to from R to S on this triangle. So if I go from R to S, I would see that X has to correspond to 27. This means that since AC is congruent to SR, they have the same length. And so I'll say I don't know why I wrote S. The value of X must be 27 by, and you could even say by, the corresponding parts of congruent triangles are congruent. So the next one, I see Z would probably be the easiest in this case, so I'm going to do Z next. Z is equal to, well, if X is equal to 27, Z has to be 29, because we see that Z is between A and B, so AB here, that would go to RT, and then, of course, RT would be 29. So Z, and maybe I'll box it instead of circle, but like, X goes with 27, Z goes with 29. They must be congruent since they're on congruent triangles. And then here we see if I wanted to find the value of Y. So the value of Y. Now I'm going to have to use some of my triangle knowledge here. And this is a refresher. Maybe I'll write it over here somewhere. Congruency. There's triangle properties that never go away. So over here somewhere we're writing triangle properties that are good to remember. And these apply to triangle congruence. So one good thing to know is that the sum of the interior angles of a triangle add to 180. So they add to 180. Some of the interior angles of a triangle are 180 degrees. All right? So in this case, that's just something nice to remember that hopefully we should know at this point. We see that 67, 73, and Y should make 180 altogether. So we know that, let's see, a good way to calculate this, 180 minus 67 minus 73. All right? And here I see 3 and 7 make 10, and then I would have 70 plus 70, which is 140. So this would be 180 minus 140, which is equal to 40. And so Y must be 40 degrees by the interior angles of a triangle. So for my final letter, I need to find D. Now, D is a little bit different than the rest. We see that D lies at the letter S. It's the angle corresponding to the letter S. And S in the other triangle corresponds to C. So if we go to C over here, we see that its angle is 67. Well, since these are corresponding angles, they must be equal. And so in mathematics, we would write that 67 degrees is the same as D minus 10. So to take away 10 degrees, and I guess I should really leave this like degrees, right? To take away 10 degrees from D and get 67, D would have to be 77. So to find that, we could have added 10 to both sides. And 10 must be equal to, and I hate to write cancels, it really goes to 0. But D would be equal to 77 degrees. Beautiful. So that's our answer for D. Now that's all 4 variables wrapped up and done. All right. So finally here we see our first example of congruency theorems. So before we do this, finish this page, I would like to add something else to triangle congruence. There is a very important, we want to know, like very importantly in geometry, you want to know when triangles are congruent. And the easiest way to do that is to use these methods of congruency. So over here we have, and I'm going to call them congruency theorems. Congruency theorems tell us when triangles are congruent. Okay, triangles properties help show. Maybe I should write that right. Triangle properties help show triangles are congruent. Congruency theorems tell us when triangles are congruent. All right, and we could say this way: triangle properties are used in congruency theorems. So, over here. Our congruency theorems that we have, we said the simplest one is side, side, side. If all the sides are the same, then if all the sides of the triangle are the same, then they must be the same triangle. There's only one possible triangle by the triangle inequality is what we proved originally. All right. The next one up was we said, hey, if you have side and angle inside, so here we have side, side, side. That would look like, and I'm just going to draw a tiny, tiny picture here. That's like when all the sides are the same, side, side, side. Those are congruent triangles. Side, angle, side, we said it was when you have whenever you have an angle in these pieces, they must be congruent by side, side, side. So we use that one to show the other one. We have also, let's see what was next, probably angle, angle side. So we have an angle, and then a shared side. That would look like this, an angle, and a shared side. We also have angle, side, angle. Beautiful. And now, this is not a great picture, sorry guys, but you get the point, right? If we have a side and two angles, and the side is wedged between those angles, right? Notice the importance of the order here. The order of these letters matters. And then finally we had HL, which is like if you have two right triangles and they share a leg and hypotenuse. So if they share a leg and hypotenuse, they must be congruent. All right, so now that that's out of the way, we can use these in this case to show if these triangles are congruent or not. I guess we could say, well, I guess we're assuming these are congruent, and we're going to use which method could best prove it. So in this case, we see that these guys share an angle, they share a side, and they share an angle. So this, to me, looks like a angle, side, angle congruence problem. Okay. In this case, these are given as equal. The hypotenuse here is given as equal. We have two angles shared here. So these guys share a 90-degree angle, which makes them both right triangles. So these are both right triangles. Very cool. And then we see in the middle, this side is shared between those two triangles reflexively. So since this side is the same, for both, we actually have a hypotenuse and leg shared between these triangles, and they're both right angles. So they're both right triangles, so we could say this is true by HL. All right. Down here, we see 72 and 72, so those are the same angle. There's one angle given to us. All right. And then here we also see a side, which is pretty cool. So there's a side and an angle, and they would be going this way, right? So side to angle, side to angle. And then here we would have another angle by vertical pairs. So that's going to be something helpful to remember here. These angles are vertical pairs. So that means they're congruent, and we have another angle, finally. So we could say these ones are congruent by angle, angle side. Typically we write AAS instead of SAA, even though they technically are the same. All right? So those are AAS, and then, oh, sorry, I wanted to write somewhere in here another property we may want to know. This is not really a triangle property, but it is involved, so maybe something good to write is that vertical pairs. Vertical pair theorem comes up where if you have like these guys, these angles are equal if they lie on opposite sides of a straight line. Where straight lines intersect, sorry. And then here, these guys share all three sides, so it must be a side, side, side. All right. That is a recap and reteach of the first page. It's the basics of triangle congruency. It's the crux of everything we will learn in all of triangle congruence. So please, if you've learned any pages, make sure you know this one. All right, I'll see you guys in the next video.